Good day, everybody. We're looking for a non-integer rational number, so I'm going to write it like this \z. That's the same thing as saying q minus z. We're looking for a rational number that's not an integer. Okay. Now you could just say find a real solution to this. You don't have to give the problem solver this much of a hint. All right, now this looks like a difficult problem. You know, large constants. You don't have zero on one side. So it looks like it might be a challenge. However, there's a nice approach here which makes it slightly easier. If we add 3 to both sides, the right-hand side becomes 0, and we can distribute the 3 as 1 plus 1 plus 1. Okay. Now, why is that a useful idea? Well, it gets down to writing 1 3 different ways. You can write this one as x minus 26 over x minus 26, right? As long as x is not equal to 26, which couldn't be a solution anyway. It'd be an undefined equation. Okay, so there you go. Now you can write this one is x minus 25. So you see, it's fairly simple, but knowing to try this idea is, it's a little elusive. So this problem is sort of the David Altizio version of obfuscation. You know, it's not hard if you can stumble upon the way to do it, but the method is kind of obscure until you actually see this, at least in my opinion. Okay, and then of course right over here we'll write 1 is x minus 24. Just cleverly disguised versions of 1 is what's bailing us out here. Okay, so we did that 3 times, and when you do that, this is what happens. If you add x minus 26 to x minus 47, you get 2x minus 73 all the way across, and that's the symmetry, I guess, is what makes it some sort of symmetry. See how we get 2x minus 73 common to these 3 different denominators. Now, the final step here, of course, is to factor out 2x minus 73. Let me write that parenthetically. All right, then we're left with a bunch of reciprocals, a bunch of non-zero reciprocals, I might add, although that's not particularly important as far as the goal of this problem, of just finding a rational solution. Extend that a little bit. Now, what's cool about this is that each one of these is non-zero, right? It's a non-zero value. It never, if you just think about what the reciprocal function looks like, it never takes on a value of 0. But we can at least, to find the rational solution, 2x, we can set this factor equal to 0. And of course that implies that x is equal to what, 73 over 2? And, I'm not, there may be another rational 0 here, I'm not sure. The only way you could find out would be to set this entire thing. There may be another one. I just said find, what was the instructions? Find an x. Okay, I didn't say find all, and I thought about it. I don't want to say find all because we can have, I think, 4 zeros here. I think 2 of them might be rational, and the others may be either irrational or complex. I'm not sure, but we did find at least 1. And again, the work, you would have to set this piece right here, which I think is kind of a challenge. Maybe it's easier than I think. Maybe you would get a numerator that factors nicely or something. I don't know. But so this problem is incomplete in the sense I've only found one solution. I didn't find any other possible rational zeros. My guess would be this would be the only rational zero, but it is. I guess it's a fourth degree equation in some sense. So or third degree, maybe third degree. I don't know. But anyway, this is the answer I got y'all. 73/2.